Hi guys, Mr. Sonnenberg here. Today what we're going to be talking about is velocity. So A, we're going to define velocity, and B, we're going to calculate velocity. So first we need to know about speed. So there's two factors scientists use to determine speed. So one, distance, which is a change in position, and the second is time. So the change in position occurs over a period of time. So we're going to use those two things to calculate it. So what is velocity though? So velocity is the distance traveled during a specific time interval. So an example of this would be a vehicle traveling at 100 kilometers an hour, which is kind of the standard speed limit on highways. It's going to cover a distance of 100 kilometers per or in 1 hour of time. So then if we had a vehicle going 50 kilometers an hour, like say in town, well, it's going to cover half the distance in 1 hour, right? Because it's not going as fast. So units of velocity though, so kilometers an hour, so that's kilometers per hour, or meters per second. So you can see the difference between the two right here. So we have kilometers an hour right there, we have meters per second right here. Now, another conversion you're going to want to understand is that for every 1 kilometer, which is right here, for every 1 kilometer, we're going to have 1,000 meters. You're going to want to remember that. And most of you probably know that already, but you'll want to remember 1 kilometer equals 1,000 meters, whereas 1 hour equals 3,600 seconds. So for conversion purposes, you might have to, in some questions, you might have to convert minutes to seconds, or hours to seconds, or kilometers into meters, meters into kilometers, vice versa. So if you just take a look on the right, there's some objects. So we're talking about the velocities, and just thought this would be interesting for you guys to take a look at this. So light travels. If you take a look at light, how in meters per second, it travels 300 million meters per second. So light, I don't know, light is almost as fast as me when I run, but not quite. So I'm pretty quick though, so a little quicker than Mr. Adamson on the other end, but I won't bug him about it too much. Then the space shuttle, take a look at its numbers as well. But then what's interesting is, when people say, oh, you're fast as a cheetah, well, cheetah runs 115 kilometers an hour. So in 1 hour, it could run 115 kilometers, right? Or 32 meters per second, which is incredible. But I didn't realize this actually when I was looking at or putting these numbers up. I didn't realize that an antelope can run 88 kilometers an hour. That's fast. So anyways, just take a look through that. We run on average about 37 kilometers an hour, or 10 meters per second. So it's interesting to look at some of these numbers, and just so we understand units of velocity and the difference between kilometers an hour and meters per second, and how we would convert and change those. So now we'll talk about calculating velocity. So the formula is going to be velocity equals distance over time, okay, or v equals d divided by t. So distance is going to be measured in kilometers or in meters, like I said earlier with those conversions, and time is going to be measured in either hours or it's going to be measured in seconds. So then what we're going to get in the end is velocity is measured in kilometers an hour or meters per second. So then I have a little note on the bottom that says anytime you know the distance of an object, or the distance an object has traveled and the time it has taken to cover that distance, you can calculate the object's average velocity over that period of time by simple division. And that's basically what we're doing here, okay? Now, if I wanted to manipulate that equation, I could do so. I'll show you how. Basically, I could just draw my triangle here. Okay, I'm solving for velocity. Okay, so we'll say that velocity is equal to distance over time. Well, if I wanted to know what the distance was, okay, then I could say, well, distance is equal to velocity times time. If I want to know what the time was, I could say that time is equal distance, which is over on the pyramid or the triangle, is over velocity. Okay, so you can manipulate these equations based on that. Okay, so if you remember that triangle, sometimes it'll help you if it's asking you to solve for different variables. All right, moving on. So when we are solving for velocity, there are 5 steps. I want you to include every time you do one of these problems. Okay, so step 1 is we want to define what we know. Okay, so if I know the velocity, or if I know I'm solving velocity and I know the distance is 10 meters, I write d equals 10 meters. I'll just show you what I mean. So I'm going to say, what do I know? Well, I know that the d equals 10 meters. What are we trying to find out? Well, say I'm trying to find out velocity. Well, I'm trying to find out velocity. Okay. I want to know what the velocity is. Let's throw a question mark. How did you find it? Well, I'm going to show how I find it. Well, v equals d over t. I'm going to show my formula. Then I'm going to plug in all the values I have. Okay. And then I'm going to calculate it as distance per time, so it might be in meters per second, and I'm just jotting down some quick notes, and then I divide the time units into distance units, and I'm going to get my calculation. Okay, but 5 steps. What do you know? What are you trying to find out? How do you find it? Show the velocity as per distance, or as distance per time, and then divide the time units. Okay, so an example problem, allow you to implement this right here. Okay, so what I want you to do is I want you to try to do this on your own. So pause the screencast with this, get a piece of paper out, and see if you can answer this. Okay, so hopefully you've had time to do that. Let's see if yours matches up with mine. So a snowboarder makes it down a 1,200 meter run in 75 seconds. Okay, so that's a minute and 15 seconds. What is the snowboarder's velocity? So we want to calculate the velocity. So first, what do we know? Okay, so the first thing, well, we know that the distance is equal to 1,200 meters, or 1,200 meters. We know that the time is equal to 75 seconds, but we don't know the velocity. So we need to find that. And again, hey, you'll notice I use a lot of like sport examples in my screencasts, hockey, baseball, snowboarding. It's just because I play sports, so this is stuff that's, I guess, relevant to me. I know a little bit about it, maybe. I don't know. So the second thing, what do you want to find out? Well, we need to know what velocity is. So we're going to put the formula for velocity. And it's going to be distance over time. That's a d. Okay, how do you find it? Well, I'm going to plug in my values. So velocity is going to be equal to 1,200 meters divided by 75 seconds. So now I'm going to show my calculation. So I'm going to go 1,200 divided by 75, and it's going to equal 16. Now I'm just going to try that again, make sure. 1,200 divided by 75 equals 16. So my velocity is going to equal 16, but what's my measure units? Meters per second. And if you didn't put that in there, you should feel ashamed. No, I'm just joking. If you didn't put that in there, make sure it's in there, okay? The meters per second, that's important. Okay, so I've divided, I've calculated, okay, and I've determined that my velocity is 16 meters per second. Okay, hopefully your answers matched up to that and you had the correct steps. So I have a practice problem for you again. Pause the screencast. Of course, it's sports related. That's my thing. Pause the screencast and see if you can answer it. Okay. All right. Let's see if your answer matches up to mine. Okay. And if you didn't pause it and try it, then it's going to seem really weird that I just started talking again. And that's your fault, not my fault. So I can't pause and wait on this thing. So anyways, just joking. I'm just calling out all the people that didn't actually pause the screencast. I don't know who you are. I probably never know who did or didn't. But I hope you tried this out. Anyways. Sore throat here. Okay, so baseball pitcher throws a ball toward home plate from 18.39 meters. We know our distance right there. It's measured in meters. So 18.39 meters. Make sure that meters is in there. Okay, we know our time. It was 1.3 seconds, and it was cool because I used to have a pitching coach that he had a little stopwatch all the time on first base, and he'd click it and he'd let us know 1.3, 1.2 how long it took for us to react to a ball when it was pitched to us. And we had some guys throwing the ball pretty hard, so it was always interesting to hear what Ray had to say to us, let us know how fast they were throwing, what the velocity was. So anyways, so the velocity of this ball, we know how long it took us, or it takes 1.3 seconds for us to react and swing in order to hit the ball. What was the velocity the ball was traveling? So I know this, so I know I'm solving for velocity, so it's going to be distance over time. Okay, now I'm going to plug in my values, 18.39, make sure you put meters, divided by 1.3 seconds. And now I'm going to calculate, so I have my trusty little calculator beside me, divided by 1.3 equals 14.15. So it's going to be 14 point, I'll just go 2 for now. And its velocity is calculated in meters per second. Okay, so this is how we solved for it. I could write a word equation at the end if I want. Hopefully your answer is matched up. 14.2 meters per second is the velocity of that baseball. Okay, so hopefully this has helped. That is velocity. We've defined it. We've learned how to calculate it. We've learned a lot. Anyways, hopefully that's helped. We'll talk to you on the next screencast. Bye.